All right. So we're going to be talking about the CBA 1 review because it's coming up. CBA just stands for Curriculum Based Assessment. It's the stuff we've been learning in class, right? So things that we should know about rational numbers, integers, and whole numbers, okay? An integer is going to be a whole number and its opposite. A rational number is going to be a decimal, a fraction, or a percentage. And a whole number is going to be your counting numbers 1, 2, 3, 4, 5, 6, 7, 8, and so forth, including 0. Okay? Now, there is another one. There is natural numbers, which is even smaller than whole numbers. That's all of your counting numbers except for 0. We're going to really focus on these, though, for now. Okay? So when we think about what we just talked about, rational numbers are going to be decimals, fractions, percentages, okay? So the first obvious one that's going to stand out to me is going to be our very first number, which is 4.12. $4.12, 4 and 12 hundredths, it doesn't really matter. So what I'm going to do here is I'm going to write in 4.12 just like that. I'm going to cross it out to know that I've used it. 0, that's not going to work. Negative 16 is not going to work. Negative 1/3, well, that's a fraction. So that will work. And so I'm going to put it in rational numbers. Remember, it does not matter if the number is positive or negative when it comes to a decimal or a percentage or a fraction. Now, I'm going to cross that one out so I know I took care of it. Negative 21/3. That can be a little tricky because it's a fraction, right? But can we simplify it? Okay, so when we divide fractions, okay, we talked about this in class. We have the cowboy hat and the horse, okay? I'll do my best to draw this, all right? So what I mean by cowboy hat and horse, okay? So here is the horse, tail, legs, head, eyes, ears, and a little mane. Okay, cool. That's my horse, right? My cowboy is, let's see, it's going to wear a little cowboy hat. Just like that. Okay? Now, why am I drawing this? Because the cowboy can only take one of these things into his house. Here's going to be my fraction box, but I'm going to turn it into a house just for a little visual. And all the way down. Now, again, the cowboy can only take one of those two things into the house, the hat or the horse. Now let's be realistic. Which one do you really think is going inside the house? It's the hat. Good. So the hat has to go inside which represents our numerator. And our numerator is going to be the number on top. The horse, well, they're going to stay tied up. Okay? And they're going to be outside. Now the horse represents my denominator. Okay? The denominator is the number that goes on the bottom. So now that we know what this looks like, we're going to take this fraction and we're going to turn it to the side. We're going to take our numerator, which is the number on top. We're going to place that on the inside of our house. We'll worry about the negative sign later. Right now we're just going to divide, and it will be negative. Our 3 is going to go on the outside of that house. So when we do that, we have our 21 inside our house and our 3 on the outside of the house. Cowboy hat, Horse. I know that 3 can fit inside of 21 7 times. 7 times 3 is 21. Therefore, I have nothing left over, but we have that negative value. Therefore, it is negative 7. So this can be written as negative 7, which changes what we originally knew, which was this fraction, to a integer, okay? Now, that's going to be big because that's exactly where we're putting it, okay? Negative 16 and negative 7 are similar in that they are going to be integers. Keep in mind that though these are negative numbers, they also have an opposite. I'm going to cross those out because we just went through them. 0 and 100. So whole numbers are going to be counting numbers, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and so forth, and 0. Okay? So because of that rule, both 0 and 100 end up as whole numbers. Cross them out. Thank you, cowboy hat and horse. Okay? So you'll see things like that on this review or on this CBA. Not exactly the same, but similar because it's covering a similar teak. A teak is going to be the educational guidelines that we follow. To make sure that what we're learning is tightly aligned, okay? Now, here we're going to be doing some true or false questions where we are really trying to analyze what it is they're asking us here, okay? So, they're saying true or false. The opposite of 2/3 is 3/2. Okay. Well, based on what we just did, right? With the cowboy hat and the horse, we can measure that. The 2 will go on the inside and the 3 will go on the outside. And then we'll do another one with the 3 on the inside and the 2 on the outside, and let's compare. All right. We'll start with blue. They're saying that the opposite of 2/3 is 3/2, 3 halves. Cowboy hat, horse. 2 goes on the inside, 3 on the outside. We know 3 can't fit inside of 2, so we write a 0, we write a decimal, and a 0 here. Now, we can really think about it. How many times can 3 fit inside of 20? 6, that's going to give us 18. 20 minus 18 will give us 2. I add another 0 here, pull it down, and you can see the theme starting to happen again and again. It's becoming a repeating decimal, okay? So I know now that 2/3, right, is really equal to 0.66. Now they're saying that 0.66 is the same thing as this improper fraction. Let's find out. Cowboy hat, horse, 3 goes on the inside, 2 goes on the outside. 2 can go into 3 one time. That's going to be 2. We subtract that. That's 1. Put a decimal here, add a 0 down there. 2 can fit inside of 10. 5 times. Is 66/100, 66%, 0.66 the same as 1.5? No. Obviously that one is false. Okay? False. Now here they're saying the absolute value is of negative 3/4 is negative 3/4. That's super interesting because absolute value is always, 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 always positive, okay? If we put, let's see, if I decided to write the absolute value of 3/4, I'm talking about the distance this particular fraction is from 0. Well, this fraction is only 3/4 away from 0. It cannot be negative 3/4 away from 0, even though it has a negative value. So the absolute value of this particular number is literally just 3/4. Absolute value, always positive. Always. Positive. Okay? This is false. Sorry, it's false. When we look at our third option, it says the opposite of 0.35, 35 cents, 35%, 35 hundredths is negative 0.35, negative 35 cents, negative 35 hundredths, negative 35%. Well, the opposite of a positive is a negative, so this one I don't even have to do anything necessarily. It's true. If I wanted to, I can draw a number line, plot my 0.35 and my negative 0.35, and they will be an equal distance from 0. So that one's true. Okay, here, again, it's saying absolute value. The absolute value of 8.9 is negative 8.9. What did we just learn? What did we just know? What did we just write? That absolute value is always positive. Again, always positive. So can the absolute value of a positive or negative number be negative? No. False. All right. Well, let's keep on moving. I think, like just a couple more. All right, big time, okay? They're saying which is not equal. Not equal. So essentially what's wrong, right? The absolute value of negative 4. Okay? So we just literally talked about how the absolute value is always positive. Cool. That works for me. So I can say that the absolute value of 4 is the distance this number is from 0, which is 4, which is not equal to the absolute value of 4, negative 4. Well, that would be equal. Negative 4 is 4 digits away from 0. 4 is 4 digits away from 0. That works. I can't pick it because they're looking for what's not equal. They're looking for what's wrong. Okay, I can go to B. B. Ooh, I got my cowboy hat. And my horse. Oh my god, my horse is getting worse by the drawing. Tail. Ears. God, it's awful. That's going to be 16 divided by 4 because the hat goes inside the house. 4 can fit inside of 16 4 times. 4 times 4 equals 16. Therefore, the absolute value of negative 4 is 4. So this also will not work. What do we also know about absolute value? Absolute value is always positive. Is that positive? And can I change that to anything else given what I'm or written the way it is? No, I can't. If I had the absolute value line, sure, but I don't. Negative 4. This is not going to be equal. They're looking for the wrong answer, right? So because that works, we can't choose it. Because that works, we can't choose it. Because this doesn't work, aka it is the wrong answer, not equal, that works. Now, why wouldn't this work? Well, again, mostly because the absolute value of any number, whether positive or negative, is always positive. 20 is going to be my hat. 5 is going to be my horse. Hat goes on the inside. 5 will fit into 20 4 times. There we go. Absolute value of -4, absolute value of -4, absolute value of -4, not the absolute value of -4, because the absolute value is always positive. Always. Absolute value is always positive. And that's why that's wrong. Because this works and we're looking for what's wrong, what's not equal, that's why that's right. Bear with me, y'all. Next one. Okay. Here we have 3 different teams. Team X, Team Y, Team Z. Okay. Team X scored 43 goals, but they gave up 29 goals. Team Y scored 34 goals, but they gave up 18 goals. Team Z scored 53 goals, but they gave up 38 goals. What they're asking us to do up top is to rank teams by their goal difference. Difference means subtraction, essentially, right? And they tell us that after goals scored minus goals given up. Okay. And then we're going to order it from greatest to least. And that's going to be important too, because we always want to know which way we're ordering it, from greatest to least, from largest to smallest. They already told us what to do. The teams are ranked by their goal difference, okay? Goals scored minus goals given up, okay? This is pretty simple. So let's do X, Team X, okay? 43 goals minus 29 goals given up. I'm going to borrow there. Difference between 9 and 13 rather is 4. 3 minus 2 is 1. So 14. Here we're going to go to Team Y. Team Y scored 34 goals, but they gave up 18 goals. Let's see what their differential is, right? What the difference is. I can't do that. I have to borrow. Difference between 14 and 8 is 6. 2 minus 1 is 1. So Y will sit there at 16. We'll do the same thing with Z. They scored 53 goals, but they allowed 38 goals. So they scored the most, but allowed the most, right? Let's see what that means. 4, 13, difference between 13 and 8 is going to be 5, and 4 minus 3 is 1. So their goal differential is as follows. X is 14, Y is 16, Z is 15. They want us to order it from greatest to least, okay? So the highest number to the lowest number. As you can see, the highest number is 16. That's attached to Team Y. The second highest number is 15. That's attached to Team Z. And our last by default, but also our lowest number, is Team X at 14. And that is how we would order it if we were given that option. All right. Last one and we're good, okay? So here they want to know which is true. And this is where the cowboy hat and the horse is going to come into play really, really drastically, okay? So first things first is we need to figure out, is 8/10, 0.8, is that equal to 1/8? I mean, no, but let's talk about why. If I added a 0 right here, I have 80 cents. So 80 cents and 1/8 is not going to be compatible, okay? If I look at my 1/8, I have to simplify that, or at least convert it, figure out what it means, okay? Again, cowboy hat goes in the house, and the cowboy hat's always on top. So I put my 1 on the inside, my 8 on the outside. Obviously, 8 cannot fit into 1. We represent that with a 0 and a decimal, and because I added my decimal, I can now draw a 0. Now, 8 can fit into 10 twice. Or twice. My bad. Once. Whew, that was close. 8 times 1 is 8. 10 minus 8 is 2. 8 cannot fit into 2, so I add a 0. Bam. Now 8 can fit into 20 twice. 2 times 8 will give me 16. That'll give me 4. Bring down my 0. 8 can fit into 40 5 times, and so that's my decimal. Now, is 0.125 the same as 0.8? No. That's false. That's not going to work at all, not even remotely close, okay? Don't fall for that. All right, B, we have 1 2/3 is equal to 12/3. Well, we did 2/3 earlier, so if we remember that decimal, really, this is what it is, okay? Now let's see what 12/3 really turns into. Cowboy hat, horse. Hat goes on the inside, horse goes on the outside. 3 can fit evenly into 12 4 times. There's literally nothing else we can do. Is 4 equal to 1.66? No. It is not true. It is not true. It is not true. Looking at C, is negative 11 equal to negative 11 over 1? Let's find out. Okay. Cowboy hat, horse. We'll come back to that negative sign. Now, how many times can 1 fit inside of 1? 1 times 1 equals 1. We subtract that. We pull that down. 1 can fit inside of 1. 1 time. 1 times 1 is 1. Therefore, once we bring this this negative sign back, negative 11 is equal to negative 11. This one is true. Let's talk about why D is not true. Okay, we have 31 cents, 31 hundredths, 31%, whatever. Here, cowboy hat, horse. Cowboy hat goes on the inside, horse goes on the outside. 10 can fit inside of 31 3 times. That's 30. That's 1. 10 cannot fit inside of 1, so I add a decimal, I draw a 0. 10 can fit into itself once. Is 0.31 the same as 3.1? No. That's why that's not true. All right, y'all. That's it for me. Hopefully it was helpful.